NASA is releasing a new image of the Milky Way as seen by the James Webb Telescope. The image, about 25,000 light-years from Earth, shows the Milky Way's galactic center. The universe just became much more interesting. The James Webb Telescope, the most powerful telescope in the history of civilization, has detected a perplexing signal from our nearest neighbor in the galaxy, Andromeda. The scientific community is in shock due to this extraordinary occurrence, and world-renowned physicist Michio Kaku has now come out to explain more about this groundbreaking discovery. Well, that's the problem, Kaku said. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. What mysteries might this signal conceal? Does it allude to intelligent life or something much more mind-blowing? Join us as Dr. Kaku explores the meaning of this cosmic message and how it affects our understanding of the universe and our place in it. The James Webb Space Telescope JWST is a space telescope designed to conduct infrared astronomy. It can see objects too old, too far, or too dim for the Hubble Space Telescope because of its high-resolution and high-sensitivity equipment. This allows it to conduct research in a wide range of astronomical and cosmological domains, including the study of the first stars and galaxies, as well as the detailed atmospheric evaluation of other planets that may be habitable. The telescope is named after James E. Webb, who was NASA's administrator from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. On December 25, 2021, an Ariane 5 rocket launched the Webb telescope from Kourou, French Guiana, and it reached its orbit in January 2022, positioned approximately 1.5 million kilometers from Earth, near the Sun-Earth L2 Lagrange point. On July 11, 2022, the first image captured by the telescope was made public. Recently, the James Webb Telescope has received an alarming signal from the Andromeda Galaxy, raising questions about its implications for our universe. Andromeda, the closest large galaxy to the Milky Way, has fascinated astronomers who have traced back the earliest building blocks of our Milky Way galaxy to 12 to 13 billion years ago, close to the time when the universe's first galaxies formed. Sometimes known as Messier 31 or M31, Andromeda is located 2.5 million light-years from Earth and is a barred spiral galaxy, similar to the Milky Way, with a prominent bar-like structure in its core. NASA estimates that Andromeda is the largest galaxy in our local group, spanning approximately 260,000 light-years, but its mass is roughly equal to or even less than the Milky Way's. Scientists believe that Andromeda could be between 5 and 10 billion years old, although it may not have existed in its current form until about 2 to 3 billion years ago, following the merger of two smaller galaxies. Andromeda is best observed on dark, moonless nights. It is visible for much of the year, particularly in August and September when it is highest in the sky. Some of its star clusters can be observed under dark skies with a powerful telescope. One such cluster is the bright male II, often called Globular 1 or G1, believed by some scientists to be the remnants of a dwarf galaxy's core that merged with Andromeda. Determining Andromeda's distance has long challenged astronomers. Early methods included parallax, which measures an object's apparent position change when viewed from two angles, but this was ineffective due to Andromeda's distance. Edwin Hubble used Cepheid variables, stars whose brightness correlates with their pulsation period, to calculate its distance, revealing that Andromeda was far more distant than previously believed and supporting the concept of an expanding universe. Redshift, where light from an object is stretched to longer wavelengths, helps astronomers calculate Andromeda's distance and motion relative to Earth. For centuries, scientists mistook Andromeda as part of the Milky Way, often referring to it as the Andromeda Nebula. Edwin Powell Hubble's research in the 1920s confirmed that Andromeda is a separate galaxy, not a mere spiral nebula. Despite its impressive size, determining which of the Milky Way and Andromeda is more massive is challenging, as both galaxies have comparable masses and similar spiral structures. While Andromeda has more pronounced features, both galaxies house relatively inactive central black holes. Andromeda's black hole is estimated to be around 100 million times the mass of the Sun, and it likely grew by absorbing smaller black holes from merging galaxies. The location of SDS-01 in the sky, although supported by fantastic technology, wasn't designed to observe objects as large and dim as this. Solving the mystery will require spectra, breaking the cloud's light into minor wavelength divisions, much like raindrops splitting sunlight into a rainbow. By carefully examining SDSO1 spectrum, scientists can determine the velocity of its gas through the Doppler effect. A slight blue shift in color would indicate the gas is moving toward us, while a red shift would mean it's moving away. If the cloud's speed resembles that of Andromeda, it's likely part of that galaxy. If it's slower, it's probably within our own. Today, the world's most powerful particle accelerator, the Large Hadron Collider LHC, reopens after 3 years of upgrades. Currently, scientists are observing something intriguing as the LHC operates, leaving all thrilled. This machine holds immense power, capable of unlocking realms beyond imagination, yet scientists at CERN were caught off guard by an intriguing discovery that Brian Cox himself recently revealed, which also involves the Mandela effect. For scientists, CERN's Large Hadron Collider is like a ticking time bomb on the edge of explosive scientific breakthroughs. Born from a collaboration of brilliant minds, the LHC has altered particle acceleration since its creation. Spanning 27 km in circumference, it's the largest scientific experiment ever undertaken. The LHC doesn't just accelerate particles, it embodies a collective dream, pursued in unity, accelerating particles too small to see. Recently, scientists were shaken by a strange event involving the collider during a high-energy experiment. Observing this event, the LHC raised questions about black holes and the Mandela effect. Brian Cox announced this intriguing event, which involves the LHC, an interesting machine indeed. The LHC, as its name suggests, is vast, being the largest particle accelerator to date. It propels charged particles invisible to the naked eye to extremely high speeds using electromagnetic fields, with activities observable through a defined light beam. Particle accelerators are invaluable for experiments in particle physics, and the LHC has achieved many scientific milestones, including the discovery of the Higgs boson. The Higgs boson is an elementary particle, sometimes called the God particle, because it gives mass to other elementary particles, explaining why things have weight rather than moving at light speed. It introduces the Higgs field, a new concept in quantum physics. Imagine the universe as a room filled with molasses, with elementary particles like bowling balls moving through it. The molasses Higgs field gives particles their mass as they interact with it. Proposed in the 1960s by Peter Higgs and others, the Higgs boson was finally discovered in 2012 at CERN's LHC, confirming a crucial part of the Standard Model and providing insights into the universe's fundamental nature, earning Higgs and Francois Englert the Nobel Prize in 2013. Since its discovery, the Higgs boson has been studied in detail, yet much about it remains unknown. The origins of the LHC trace back to post-World War II, when European scientists united to establish CERN, now the world's largest particle physics lab near Geneva, Switzerland. Beyond scientific endeavors, CERN's innovations, like PET scans and the World Wide Web, have global impacts. Today, more than 10,000 scientists from over 100 countries visit CERN annually. The LHC, created at CERN, can smash protons at high speeds, recreating conditions akin to the early universe, allowing scientists to study the Big Bang. The LHC's components, like its beam pipe, accelerating cavities, and superconducting magnets work together to smash particles nearly at light speed. Detectors like ATLAS and CMS analyze particle collisions, shedding light on matter's fundamental nature. A recent experiment using the LHC created a mini Big Bang by colliding lead ions, reaching temperatures millions of times hotter than the sun. This feat offers scientists new insights into plasma from moments after the Big Bang. However, the LHC's immense energy has raised concerns about safety. While CERN ensures precautions, historical incidents like Anatoly Bugursky's accident remind us of the risks. Some scientists worry the LHC could create tiny black holes, though CERN assures they'd be harmless and short-lived. Meanwhile, the Mandela effect, a phenomenon where many share false memories, has stirred speculation. Some believe the LHC's experiments could be distorting reality, causing cracks that blend memories with those from parallel universes. While parallel universes are still theoretical, concepts like string theory support the possibility, describing particles as strings vibrating in higher dimensions. Gravity, being weak relative to other forces, may even interact with these dimensions. If CERN's experiments indeed affect parallel realities, they could disrupt cosmic balance. However, proof of parallel universes remains elusive. As CERN continues its research, the potential discoveries and their implications for reality and our understanding of the universe are vast.